Good morning, good afternoon, or good evening, wherever you may be, and whether you're watching live or archived. And welcome to episode number 68 of the Nautel Transmission Talk Tuesday webinar series. I did have to glance to the left to see the number. You'll forgive me, it's been a busy month. Today, last week, you remember we were talking towers and tower climbers and a lot of FM stuff. Today, we are focusing on AM, ancient magic. And to do that, I've got somebody that knows a lot more about this stuff than I do, as always, and somebody who I'm honored to call a good friend as well, Mr. Michael Patton. Mike, welcome, and thanks for being with us.
Thank you very much, Jeff. It's my honor to be here.
And so we kind of, Mike and I, to give you the backstory, Mike's dog likes me, and I think that's a good thing. Oscar's an awesome little fella, but I'm also told it can be an exception.
Yeah, he only bites people he likes.
Oh, there you go. That explains the scars. That's a good sign. But anyway, so we got talking about this, and for the folks that don't know, and I haven't looked at the audience list yet, but Mike does a lot of AM work, and you're one of the guys, probably one of the biggest names when it comes to refurbing old transmitters too.
Yes, I think I could lay claim to that. The credit all goes to my crew. They are resourceful and courageous and good looking, but they are also very, very good at rebuilding transmitters. And in fact, right now, we're working on one of your products. We have an old Nautel AMFET 2.5 that we are in the final testing stages on. And when they're done with that, they're going to turn their tender administrations to an AMFET 10. So
I remember seeing an email or two about the 2.5, and I'm looking forward to the 10. That's the one that that's the one that I tend to be a little better on. So that'll be good to see those emails.
yeah.
But, and for those that don't know, Mike reaches out to Steve on occasion, and Steve is in our shop probably the wizard when it comes to those things, because there's not too many people that have been around them more than Steve has. Joe Fleming mentions that he hopes he's the person that his dog thinks he is, and that's a good way of putting it. All right, so what we're going to talk about, first we're going to do the mandatory housekeeping stuff. All right, if you're used to these, then you're very familiar. We do have the little question window where you can throw in questions, comments, criticisms, concerns, sarcasm, snark, all of the above. If I don't bring it up on the screen and talk about it live, I will be mentally reporting it and grading it. So, you know, make it interesting at least. But definitely type your question in, hit the send button. It'll pop up on my screen, and we'll fit it in whenever we can. If you've got a microphone and you're not shy, there's a little hand wavy icon. If you click on that, it should light up something on my screen if I happen to think to look for it. And at that point, we'll open your mic and make you part of the conversation. If you're an SBE member, Nautel webinars do qualify for half of a recertification credit under category I of the research schedule. So grab your notepad, your spreadsheet, whatever you scroll those things down on, and add it to the list. On that note, let's roll up. Advanced questions, we did have some. I very dutifully sent Mike an email this morning that said, hey, here's a copy of the advanced questions. I just kind of forgot to attach them. So these are new to him too. So, you know, be gentle. But these are the kind of things that folks were asking about. And we will be addressing them as we go. If I missed anything and you asked it and you see a point where you think we really should be addressing this here, type me a little prompt in the question box just to wake me up and give me a nudge, because of course I get going and I stop thinking. It's what do they say, when mouth's in gear, brain's in neutral, something like that. So on that note, let's roll. Now, one of the questions, the first thing, Mike, was a checklist for after a station acquisition. And in the interest of security, I kept everybody anonymous, although this one was specifically requested to be that way. But I mean, really, the best time to do the checklist would be before the acquisition, right? The due diligence process. Although
that would be the best thing. After you've already bought the pig, to discover it's not what you expected it to be. You know, isn't there an old saying about that, buying a pig in a poke?
There is. One of the things, of course, we all know that there will be times where an owner will come into your office and say, hey, by the way, I just bought another station. Could you go take a look at it? So what are the things, if you were walking in, I mean, these are the things that came to mind in a few minutes, and we'll see pictures of various things as we go, but what are the hot things, the things that I guess kind of catch you as being things that can cost the most and be least obvious, I guess?
Well, it's sad that a lot of facilities have gotten to the point where you have to ask, is the roof leaking? Basic questions like that. It used to be that you had to worry about things that were at least somewhat more detailed than that, but it's really gotten back to the basics. Is guy wires have plants going through them? Insulators cracked? Are the doors on the ATUs secure? Are they even there? Safety issues, like, is there a fence around the tower? Is there a gate on the fence? Are there signs? Because this is the sort of thing that the FCC will get you for. So I think the first level of questions I ask is the site going to work? Is the building secure? Is it subject to vandalism? Then it's FCC stuff, signs, fences, gates, things of that nature. And then let's step down to the next level is the grass cut? Are the guy wires clear of weeds? Anchor points are good. Um, you know, Things like that. And then you get down to does the transmitter work? Does it make licensed power? Does anybody even know what licensed power is? And you can just walk down the list there.
Yeah, and it's funny that you bring that up. I mean, I have had more than one call over the past 30 odd years where somebody said, yeah, we got off the air on the way to the site. What could it be? Well, that's always the question, guaranteed to make it into a presentation, because it's like, until you can tell me what lights are lit, I have no idea what it could be. Off the air it's like telling me that my car won't start. But we'll call you back in half an hour, and the 2 or 3 hours or days go by, and it's like, yeah, sorry, we couldn't find the keys to the transmitter building. Or my all-time favorite, we couldn't find the transmitter building.
Right.
That call happened once.
Yeah, that's one of my touchstones. Is does the owner know how to find the transmitter site? If he doesn't, that's a bad sign.
Yep. And I mean, I think one of my other favorites was the leasing company called, said, yeah, we're on the way to repossess this transmitter, and just wanted to verify the address. And it's like, not my job to tell you that. What are you driving? Well, we're in a half-ton pickup truck. You realize that you're picking up a transmitter that's 14 feet long and weighs 8,000 pounds, right? Might need a bigger truck. So anyway, now Andy's asked, and he's hitting it on it right now, what are the current FCC requirements for remote monitoring an AM array? And so the FCC requirements, as I read them these days, are basically, you have to be legal. How you do that's up to you. How am I about right on that?
That's my understanding, is that the rules are pretty short on specifics these days. And you have to turn the transmitter off remotely. That's carved in stone. And if as I understand it, if the FCC says, can you prove whether you were operating in accordance with the terms of your license or not, your answer had better be yes. But until and unless the FCC comes calling to ask that question, then it's a gray area. Obviously, if you have tower lights, you're expected to either have the neighbor log them every day and some way to prove it, or to have your remote control tell you that, or hopefully these days you've got a remote control with an alarm. If those tower lights don't come on, it fires up and sends you an email or a text. But the rules are short on specifics these days. And you certainly don't need, as I understand it, and I do a lot of DAs, you don't need to remotely monitor all the antenna monitor readings anymore. That went out the window a long time ago. So don't obsess about tying your antenna monitor to your remote control, because that's just a whole much ado about nothing, as Shakespeare is.
Now, I'm going to quantify that a little bit, because if you do have and it doesn't necessarily have to be part of your public file, but if you do have a transmitter log or a log somewhere where you're keeping track of phase and magnitude per tower on a semi-regular basis, then at least it shows some intent to maintain compliance. So if they come by and they go, well, when did this come out of whack? And this is, again, making the very large assumption that somebody will actually show up instead of just doing an online check of your public file and finding you based on that. But assuming somebody does come by, then having a fairly regularly updated log of various readings gives you helps you to avoid willful and repeated. Would that be accurate? And I mean, I know I'm making you interpret the rules here.
Well, I am not an attorney, nor do I play one on TV, but or a podcast. But yes, it's never a bad idea to keep good records. And I mean, you could go down to the dollar store and buy loose leaf notebooks, 3-ring binder things, 3 for $1. And whenever I take over a new site, and I don't do much contract work anymore, but I do some. I go down to Office Depot and I'll buy a nice little log book for about $8 or $10, and it looks nice. And I bring it to the site, and every time I'm there, I write down who was there, when I was there, what I did there, and what I saw. It doesn't take 5 minutes, 10 minutes, and then not only do I have a record, because if I come back a year and a half from now, gee, I wonder what I did when I was here in June or whatever. But if someone questions me, look, here's the log. Here's the proof I was there. If the customer says to me, well, you sent me this bill, I don't know if you were there. Well, here's the log. Here's what I did that day. So that's just common sense, and it doesn't cost you anything. It doesn't take anything. It takes 5 minutes.
Now, one of the things, and I don't have it right at hand, but one of the things I use a lot, I've got it's made by a company called Rocketbook, and it's a little notepad with, you use Pilot friction gel pens in it, and then you can give them a little scrub, and they're erasable. You can write over them. The cool thing about Evernote Evernote is the app I use the Rocketbook with. Yeah. Because if I save the notes to Evernote, it'll save them as a PDF that you can then scan with OCRs. So if you want to know when was the last time I looked at the tower light controller or measured the base current, then you've got that information. So that was that's having some sort of note and some sort of log is a really, really good idea from a maintenance perspective.
Yeah, I have one of those around here somewhere. That's the phrase that my company, it's around here somewhere.
Yeah. That's what my wife says. I can't find it anywhere.
Right. That's good technology. It's a good hybrid technology. For us old timers who are used to writing everything. And another thing that I do, not so much for that sort of thing, but just in general, I have a couple of little note-taking apps on my phone that I'll write down things like passwords and logins and things like that. So if I come back to a site and gee, what was the password for this remote control? Well, call it up, search for the call letters, boom, there it is. Because I'm terrible about writing something down and misplacing the paper. And that way I don't have to keep up with the paper because it's in my phone, it's backed up to the cloud, it's always there. And I'm sure there are more extensive note-taking apps that you could like dictate into or even do videos if you wanted to throw a bunch of data at it.
No, say for me, the app I like is called Evernote. William had asked what it was called again, because Evernote will let you do pictures, videos, handwritten notes. You can do pretty much whatever you want with that. But yeah, like you say, just find one that works for you and document everything.
Yep, I agree.
Now, Mark had asked whether I said the Canadian version of the FCC requires tower light monitoring. And Mark, I have to admit, I don't know the answer for that. Our tower is, we're leased on a power company tower, so it's their job to look after the lighting. I will look that up and send you an email on that. So if anybody else needs to know, fire me a comment in the question, send me an email or whatever, and I'll include you in the answer. Let's see. William, the actual notebook itself, for taking your handwritten notes, where you can, it's got a series of icons at the bottom of the page so that you fill in the icon and you program the app to do whatever you want when you scan the page to the app. And based on the icon, like some of mine will go to Gmail, some will go to Evernote, some will go other places, but it's called Rocketbook. So just rocket like the spaceship book, B-O-O-K.
You got it. Right. Things like that. It's readily available.
Yeah.
It is. Send you 12 cases of them tomorrow.
So it is a pretty cool toy like that. I have not put anything in there, and yeah, you're not. I should tell you, Mike. I see you sent the note. So for what it's worth, folks, I get the questions. Mike doesn't get the questions, so we're relying on me. So if we don't answer your question, that's on me, not Mike. We'll put the credit where credit is due, or the blame where it's due, right off the bat. Now, so we're doing our due diligence, and one of the questions we'd gotten in the advance was talking about soldering grounds and stuff, and I'm here to tell you that ground resistance, so we've had the discussion before about tuning units, and one of the things, and that's not a tuning unit, obviously it's a Kintronic isocoil, but one of the things that people ask a lot is why we don't provide tuning units with our AM transmitters. And my argument, and I think Nautel's argument as a whole, has always been that that's really the job of the phaser or the ATU, not the job of the transmitter. That if you have to adjust it, you really should be solving the problem of why it's changing. Now, sometimes if you're in like a tidal marsh, your impedance is going to change twice a day, every day, no matter what you do. But inland, it should be pretty stable. Things like this are some of the reasons it can change. You know, vice grips aren't necessarily the best way of connecting a ground. But so, Mike, talk to me about that a little bit. Like ground resistance, of course, between wet season and dry season can change a lot.
It,
What are some of the things you do?
well, obviously, you start with a good ground system, competently installed. Unfortunately, a lot of AM stations' ground systems are getting pretty old these days. They're probably old enough to have grandchildren. Um, and ground systems do deteriorate. It's hard to measure the actual performance of a ground system, which we can get into, I think, a little bit later. I saw one of the questions. But look for breaks. Make sure that whatever you've got is as good a shape as possible. Don't put it together with vice grips. If you have to repair a strap, always use silver solder. Not cheap, but readily available at any good welding supply house. You can silver solder with a MAP gas torch, which you can buy at Home Depot. You don't have to have an oxyacetylene torch unless you're doing really serious work. And those are available, readily available as well, actually at Home Depot. It's a few $100s. Just look for breaks, look for things that make it unstable, look for poor connections, make sure your ATU is well grounded, because the shunt elements in the ATU are very much part of the load impedance of the transmitter. And if you've got a little tiny pencil neck wire to your ATU or a loose strap, you will see instability there. Look at the base insulator, make sure that the straps are well connected and robust to the base insulator, the bottom of the base insulator, because that's a 50 puff capacitor, the base insulator in any tower. And anything other than a very, very short tower that's very low impedance to begin with, you know, that the capacitance of the insulator is something to take into account. So if your insulator is not solidly connected to the ground on the bottom, you will have some instability issues.
Yeah. And that's a good point. It's not just the physical components, the inductors and the capacitors. I mean, if you look at it like an antenna, and I remember this from when we were doing, well, when I was doing support on navigational beacons, because those are very short antennas based on relative to the wavelength. They're incredibly electrically inefficient. So everything is a big factor. So, I mean, you're looking at ground resistance, series resistance, and the actual antenna resistance itself. All three of them add up to make the load resistance. It's not just one thing or another.
No, it's not. You have to look at the equivalent circuit of every part of the physical construction of the antenna if you're going to try to develop a model that's actually predictive of reality and understand what the relationship is between the physical world and the electrical performance of the transmitter and the electrical performance of, you know, this thing we call radio. You want to put signal out to listeners.
Yeah, and that kind of comes back to that. And I'll give an example. We had a site in Tennessee where in the after a rainstorm, you could measure the antenna system, and if you swept it from the transmitter output, it was 40 minus J11. And after a couple of days, when hot sun, no rain, then it'd be 60 plus J something or other.
Boy.
And what had happened, there was no connection between the tower, the ground rod at the base of the tower, and the ground rod for the transmitter building. So, you know, they're two totally separate entities relying purely on the coax shield and earth resistance, which is at the best of times not ideal.
No, the Earth is not a reliable conductor.
Yeah.
Ask the power company how that works.
Yeah, and well, the first time you and I met was that 10 kilowatt site in Memphis.
Yep.
And we chased that dog for 3 or 4 visits before we found that it was a power pole ground pig, or power pig, or try this again, pole pig, that the transformer, the ground wire coming down went into the earth at the base of the pole, but didn't actually connect to anything.
Right. And I forget who finally solved that. I think it was one of the people up there.
It was my boss, Wendell.
Yeah, that's right.
Yeah, he was in engineering at the time, and he got sent down, and that's what he finally found was, he just happened to grab that ground wire and give it a tug, and it came up in his hand, and he said, "Uh-oh."
Well, that was a unique site with a unique system. That was a corner grounded 243 phase, which
Yeah.
you see very seldom, but that was part of the reason that was so unstable.
Yeah, and now Jesse mentions for strap, he found a twin torch in plumber supply. Putting twice the map into the work makes it easy and quick, even with a breeze. Goss, GOSS was the brand he found. So just map gas torch assembly in plumbing supplies, and that makes sense because when you're brazing copper, soldering copper, you need a little more heat too.
Right, but if you're just doing strap to strap, you could do that with a standard Home Depot map gas, what they call a swirl torch. If you're trying to braze copper to, like the flange of a tower or something like that, then that's where you have to have an oxyacetylene.
Right. And the other challenge too, if you're doing to like a tower flange, then obviously you want to take the paint off and the rust and what do you do to clean it?
Well, if you're doing copper to copper, I use a wire wheel. You'll be there forever with a wire brush. Let the drill do the work. Take it down to clean. One of the odd things about silver solder as stuff to braze with is that it normally does not require flux. Almost everything else does. But dirty copper, even with silver solder, benefits from flux. Because as the flux heats up, the rosins or the acid in it are released to do their work, and they clean the material for you. So that's something to consider. Clean copper, you don't need flux. Dirty copper, clean it up with a wire wheel on the drill, paint it with some nice paste flux. Again, any Home Depot, any plumbing supply place makes it a lot easier to deal with it from there.
Okay, cool. One of the questions we'd had earlier on with again talking the due diligence, and one of the things I'd mentioned was looking for cracked insulators and capacitors. And so just let's talk a little bit about tuning units in general. I mean, so I scammed these off a ham website, and he said very clearly that if you include my URL, you can use them, which is why I chose those, because the whole not wanting anybody to come after me for scavenging their work. But in his case, he was quite insistent that the L network was more efficient. And I've always argued that I'd prefer the better isolation of a T or a pi. So what's your feeling on it?
Okay. With tuning networks, you're worried about two things. You're worried about impedance matching and you're worried about bandwidth. An L network only gives you one solution, that because you have only two components to work with and you have two goals, resistance and reactance. Whatever the load is, you're going to be stuck with a phase shift to make it match back to 50J0. And if that does not give you optimum phase rotation between your carrier and your sidebands, too bad, so sad, you chose to only have two components. A T network or a pi network will allow you to independently vary the match back to 50 ohms and the phase shift through the network, which is phase rotation if you plot it on a Smith chart, which gives you what's called Hermitian symmetry, which is equal droop or equal rise at the sideband frequencies, and then a symmetrical one way or the other, or hopefully zero, reactance across the bandwidth of interest. And your new transmitters, your current line of transmitters, the NX series, does a very good job of that because it uses the modulation to plot a nice little Smith chart on the screen on the front of the transmitter. And next week, I am going to a station in Washington, D.C. and installing an NX50. And I'm looking forward very much to using the little built-in display there, which saves me a whole lot of grief in terms of trying to play with the phaser inputs or the ATUs and rotate the phase around, because this way all I have to do is just watch the display, make a change, right. Make a change, make a change, whoop, whoop, there we are.
Well, and the advantage too is you're looking, electrically speaking, at the amplifier output so that you don't have to compensate or allow for phase shift through the filter as well.
Right, and then that brings up an entire discussion that's been going on for years and years and years about where do you measure the load impedance, what's best. This transmitter wants this curve, this transmitter wants that curve. Various experts said various things. My position has always been transmitters are tested into a dummy load. You make your load, your antenna look like a dummy load, check the box. From there on, if there's a problem, go beat up the designer of the transmitter. You've done your job.
Yeah. Now, but you bring up a really good point. And of course, with when we're talking about HD radio, AM IBOC, and I see Dave Colasar's in the audience, so Dave will know this, but and there's been a lot of discussion. HD radio really likes a symmetrical load. Now,
Yes.
I'm going to quantify that because if you step backwards not too many decades, AM stereo also really likes a symmetrical load. And when you get right down to it, AM mono into a symmetrical load will tend to go a lot farther and a lot cleaner than it will into a crap load.
Yes, and it tends to give you lower distortion at the sideband at higher frequencies, and it definitely improves the recovered audio bandwidth in most radios. And again, that's been a robust discussion over many years. I did a lot of AM stereo installs. I did 47 for Motorola, for Delta, for VE, and I even did a con system or two, although I probably don't have to talk about that. And I found about a third of the time or more, and one of the first things I had to do was fix the antenna before I could do anything else, because until the load was good, nothing else would be good from there. And God bless Motorola, they threw a lot of money at an AM stereo, gone now. But they basically told us installers, they said, we want it to work. We don't care, there are limits, but we don't care how much you charge us. We don't care how much you have to do to fix the radio station. But when you leave, we want it to sound good, because when you leave, if it sounds bad, we look bad. So we're going to throw money at it, which was great. You couldn't do that these days because the economics just don't work. But that fixing the bandwidth was the first thing we looked at before we did anything else.
Yeah, and that's really one of the things that I mean is I don't know a tactful way to put it, so I'm not even going to try. Ed, plug your ears. But AM's sort of become the redheaded stepchild, and when we were doing HD, I mean, going back, it's been 15 years since I was doing HD installs on the regular. And out of 50 to 100 HD installs I did, I would guess 2, maybe 3 of those antenna systems were properly optimized. And the rest were varying from really bad to just moderately bad.
Yeah, I see a lot of that. The last major AM project we did was up at Little Rock, KAAY, and that was the next 50 of yours. And I was able to match both day and night loads using the display on the transmitter and the phaser. And yes, it made a difference. That station sounded great when we got it back running. It was just gorgeous.
Yeah. Well, and I told somebody once that I guess don't know the best way to put it. Again, like I said, it's a fine line between being tactful and being me. So sometimes we tiptoe down that line. But another station in Little Rock that I've got a few pictures of in a little bit from a previous ownership, so I don't mind sharing them now. But they 880 with a 50 kilowatt in, you know, your north end of the Delta almost. I mean, that system should go out pretty well. And it was barely covering Little Rock. And it was a combination of a couple of things: no ground wires, antenna tuning. I mean, one tower, it shouldn't be that big a challenge, but it was, yeah, and it wasn't any one person's fault. It was a combination of things,
Well,
but
that's like
yeah,
dog for years, you know.
yeah.
Several
And that's another example, or another thing though, it's not just the tuning. I mean, the tuning makes a big difference, but if you don't have any radials in the ground, you're shooting the signal straight up, not out.
if it's going anywhere at all. Yeah.
Yep,
And
yep.
I've seen
So,
sites that were just poisoned from the get-go. There's one in Alexandria, Louisiana, where they decided to make an AM and an FM combo. The tower was like 700 feet tall on 1410, because that's what worked for the FM. And they put an upper set of skirt wires on it, but it turned out that even that wasn't enough. The tower was like 3/4 of the wavelength tall, so all the power went up and nothing went out. And they finally
now,
gave up, went back to a quarter wave tower a couple of miles away, and it got out a whole lot better. Surprise.
so here's a dumb question, and I mean, I know cost is obviously a factor in this. How hard would it have been to turn that into a Franklin and just feed the bottom half with the AM?
Well, that's a good question, and I'd have to sit down and work it out. But even then, yeah, you could have done 2 sets of skirts and driven it from the middle. But oh God, it's 350. No, that wouldn't have worked. That's almost a full wave dipole. It just didn't work. The only way to have made that work would have been to have done 2 sets of skirt wires on the top, and then either drive it at the base or a 3rd set at the bottom. And I've seen that, and I've seen it work. But you know, at that point, it's like, just build another tower for the AM. You know?
Yep. Sometimes it's you know, sometimes again, it's all cost versus benefit.
Right.
And so here we are. Oh, look, there's Little Rock right there. So we were talking earlier about due diligence, and again, this is 2 owners ago. Current owner has fixed a lot of things up. It looks nothing at all like it does in these pictures, so that's a good thing. But they were again, they were complaining about the coverage. You know, now it's a safe bet that if your tower has got trees growing through the guy wires and your tower fence consists of a gate with no fence, that your radials probably have seen the same level of maintenance. Is that's a fair assessment in your experience?
Or worse, my experience is that tree roots don't like radials. Radials don't like tree roots. And
Yep.
you know, if you've got a bunch of tree roots growing through your radials, they probably have been encouraged to corrode faster than otherwise.
Mm-hmm.
That's if the farmer doesn't come out there and till them up and I wonder what all these wires are in the ground. You know.
Yep. Well, and that is a big deal. I mean, up here, well, you've got 2 choices with an AM in this part of the world. You either run them above ground, because out on this coast it's all granite, so you don't bury them unless you've got dynamite, and you know, the neighbors tend not to like that. Or you are into the center part of the country where the frost line is 3 to 3.5 feet deep, and if you don't want them torn apart by frost heaves every year, then you're going down 3 to 4 feet.
And that at that point, they're not very efficient as a ground.
And that's the other question: how deep is too deep?
Conventional wisdom is 6 to 8 inches. And conventional wisdom is that anything deeper than that, the deeper you go, the worse the loss is, because you've got the loss of the earth, which is not a good ground, between grade level and where the radials are. And I'm not the world's best theoretician on that, but that's been my experience. That you start burying radials more than about a foot deep, and it's not going to work.
Okay. And obviously the other thing, and if you look over to the right, you're looking at the bowl insulator at the output of the ATU feeding the tower, and you can see the ant nest inside the insulator, and they were complaining that every time it got raining or wet, the transmitter started to shut back.
Oh yes, I've seen that, and I saw another thing that a humorous one, but you have to be careful. I've seen that a number of times over the years. not bowl insulators, but ceramic insulators at the bases of towers are generally hollow, okay, for structural reasons. And they have a weep hole at the bottom and generally some sort of hole at the top in the middle. And if the weep hole gets clogged, the base insulator will fill up with water and things that attract water, like spiders and ants and algae and mold and lichen and all that sort of stuff. And this can sometimes make the insulator boil over or arc over. One time in Georgia, we had a big self-support where the insulators were fantastically expensive. We ended up screwing a temp anchor into the ground, cranking the tower over by about 5 feet, taking one of the insulators out, taking it inside, running it through like 12 baths of bleach with a high pot tester. And every time we bleached it, it got better and better and better and better. When it got to the point where the 30 kilovolt high pot tester wouldn't make it arc over anymore, put it back, put the tower back, crank the thing back, fired up, worked like a champ. Even funnier, one time here in Baton Rouge, we were at a transmitter site, and the transmitter would run about 5 or 10 minutes and shut off on this work. And so let's go out to the tower, measure the impedance, which is great. Let the transmitter run. The 50, the ATU input got worse and worse and worse and worse. And all of a sudden I hear this whistling sound. The base insulator had filled with water, and it was acting like a percolator, like a kettle.
Tea kettle, yeah.
Tea kettle. There was steam coming out of the hole at the top of it, and the water started boiling. It changed the impedance. Got a pipe cleaner, cleaned out the hole at the bottom. Gallon of water ran out. End of problem.
Nice. And I mean, you could have held a mug under it, thrown a tea bag in there, made a cup of tea while you're at it.
Yeah.
Might not have been the tastiest. The RF, it adds body. And I mean, I think my best one from field service, and I was telling this actually in New Orleans there last week. Holy smokes, it was only a week ago I saw you. It just feels like forever. I came back from New Orleans, ended up with a sinus cold, but we blame that on the boy because he brought it home from school. And it wasn't COVID, so we're all good. Anyway, but I was at a site in an unnamed location, not on this continent, and putting in a 25 kilowatt. And transmitter came up. It's running for a little while. Everything's good. And all of a sudden, it's tripping with SWR. And it's like, huh. So we shut it down, and of course, I'm installing a transmitter, brand new. The first thing I think, well, I missed something. There's something loose in the output filter. So I tear the filter apart, go inside, check all the nuts and bolts. Everything's tight, everything's solid. Put it all back together, bring it up. It's running good. A couple of minutes later, starts arcing. Huh. Shut it down, put a bridge on the output, bring it up, it starts arcing immediately. Bring it down, move the bridge. Actually, we checked a few things, bring it back up, and it's running again, and everything's beautiful. And so we get to the we get to the base of the antenna, and at the base of the tower, I'm starting to see the load impedance. When the transmitter gets to where it's shutting down, the load impedance is jumping around. So being young and dumb, and before we were big enough to have a safety committee and OSHA and all those things that make you live longer in spite of yourself, I start shinnying up this tower, and I get to the first tower mass junction, and every bolt is backed off 1/4 of an inch. And I said, yeah, this is about where I stop. And I shinny back down, and they sent somebody up, and every bolt in the entire tower was like that. So the breeze would pick up, and the whole tower was sort of doing a little bit of a twist and shout in the wind. So,
wow.
Yeah. One of the questions come in: why do some transmitters need output matching network and others don't? And I guess I mean, there are some manufacturers that do provide fine matching networks, and I guess it kind of depends partly on the SWR tolerance of the transmitter, and some of it just comes down to the design philosophy of the company, right? As I said earlier, our position's always been that should be adjusted in the ATU. Now, what's your take on it? Have you had a situation where you'd rather have a fine matcher than tweak it out or tune it out in the ATU or fix the antenna problem?
The short answer is yes, because not everybody is willing to allow me the budget to fix their site. So, if someone has a transmitter with an antenna that for whatever reason, either they won't or sometimes they can't fix the impedance mismatch. There's stations where getting to the ATU is very difficult because it's in the swamp, or it's 20 feet up in the air, or it's detuning for some other reason that it's not stable. Then being able to fine match the transmitter into a less than optimum load is a handy thing. But again, as you say, it's a design philosophy. Harris/Gates Air kind of went back and forth on this, depending on the model of the transmitter. BE, same way. The little AM1As don't have a matcher. You can buy it as a separate unit, bring your wallet. You guys, I don't even think sell a fine matcher of any kind.
No. We tried it once for a very, very brief period of time at the 1 kilowatt level, and it went away almost immediately.
Yeah, and some of BE's higher power boxes have it built in, and others do not.
Right.
So I find it. The pros are that it allows you to correct a less than perfect antenna. The cons are it's another thing to fail. It's another thing to get dirty. It's another thing with a component that's going to blow up. It's another thing to have to worry about heat under some circumstances, and where do you put it, and everything else. All in all, if it shows up, great. If I put in a transmitter without one, I don't run out to spec one. Let's just fix this.
Yeah, and you brought up a good point too. It's like I say, sometimes you don't have the ability to fix the antenna system. And when you get into some of the directionals, some of those can present some really interesting challenges. And I've got a picture coming up a little bit about one, but I ran into a 6 tower in not too far to your east, a couple of states over, where no less than Ron Rackley himself, rest his soul, had looked at it and said, yeah, I can make this one pass HD. We'll just knock that tower down. We'll put 2 towers up over there, move that tower 100 feet to the left, $1 million, piece of cake, you're done. So sometimes, like you said, you do got to make the best of a bad situation. And in that case, maybe it's the option, but
well, there are some directional antennas that you're not ever going to get good bandwidth out of because of the inherent design of the array. High tower count inline arrays are infamous for this, very narrow bandwidth. Anytime you have an array that has a high RSS to RMS ratio of the fields, you're almost certainly going to have bandwidth issues, and there's only so much you can do to cure them, no matter what. Most phasers, we hope, have front panel adjustable controls for input resistance and reactance. But again, that just allows you to match it back to 50 ohms unless you have access to all 3 of the components in the common point matching network. You're not going to fix phase shift / bandwidth issues that way. But I mean, you can. But sometimes you run into a phaser where especially older ones, they assumed that would never be an issue, or they didn't care because it was designed for a tube type transmitter that was pretty forgiving as far as load is concerned. So you have to go play around with taps in the back and 2 people and everything else. Not always a piece of cake.
Yeah. Now, this is my buddy Kent standing in the WISN phaser in Milwaukee a whole bunch of years ago, because his hair is not red anymore. But of course, then again, a lot of us have changed colors over the years. But this is
by that point.
Pardon me?
I hope he had already reproduced by that point. That's a lot of power have to be standing in front of.
I don't think it was powered up at the time. But this is so ISN is a 6 tower day, 9 tower night array.
Cool.
And it's I just grabbed the FCC screenshot for the nighttime setups. But so something like that, I mean, I guess general approach to troubleshooting as a rule is to break stuff into bite-sized pieces. And I know I played with a 9 tower in Ontario for very briefly during a visit, and the guy there that knew a lot more about this stuff than me said, well, the easiest way to do it is to hit each of the 3 legs at a time. So, tune that leg, tune that leg, tune that leg, and then bring them all together. He goes, it sounds easy. It's not. But you get a feel for it. And I've noticed just tuning filters in general, after a while, you will get a feel for what components if you adjust this, I know I'm going to have to tweak that to compensate, sort of thing. And it's that a fair assessment that you kind of get a feel for it as you go?
You do, and part of it is just doing 1,000 DAs and getting a feel for what happens in general. And another thing for me is any individual array, if I'm trying to walk the parameters in, like you say, after a while you get a feel for if I raise the power in tower 2, I'm going to change the magnitude or the phase in tower 4 and that sort of thing. Some of it you can look on the diagram and say, oh yeah, 2 and 4 right next to each other, that sort of thing. So yes, for me, tuning an array, I definitely get a feel for it as I go, and I can get more and more into it and in my head, and I can walk it in. But then bandwidth is a whole nother issue, and a lot of that is literally the physical layout of the array. The second thing is who designed, how good the phaser design is. There's some good phaser design programs out there these days that allow you to predict bandwidth. And the real world is pretty, the models are good. The real world will behave the way the models say it will most of the time. And phaser designs are not all equal. For a given set of towers and a given parameters, you can have a phaser design that works well and another one that works not so well. But if you're handed somebody else's design, you've got somebody else's layout of the array that had to make the pattern. You've got someone else's phaser design that may or may not have taken bandwidth into consideration. You're coming up to the plate with a count of 0 and 2. So sometimes it's mighty hard to get that ball into the outfield instead of watching the third strike go sailing past.
Mm-hmm. And now I'm going to throw, speaking of that third strike, I'm going to throw a curveball at you, maybe more of a knuckleball. So negative impedance, towers that absorb power instead of putting it out.
Okay.
And that's two separate things. So I've heard of negative impedance. My mind still has a little trouble wrapping around how it can exist. So talk to me about that. What is a negative impedance tower?
Okay, well, first off, a lot of people confuse the difference between the tower with a negative phase shift in the parameters and a negative tower. In an array, directional antennas, in this business, we feed power to each antenna in an array. Their fields add constructively or destructively in the field, the far field, to make the pattern we want it to make. You can build an array with parasitic elements where you only drive one and the others are grounded, or they are tied to ground through a passive network, which you can vary. So you vary the power and the phase shift in the parasitic elements. That was not approved by the FCC back in the day because it was not considered stable enough. Okay, so we drive each element. But a Yagi or a long periodic is an example of an antenna with one driven element, a Yagi one driven element, and everything else is parasitic. There's nothing that says you couldn't build the equivalent of a Yagi in a field make a DA out of it. You certainly could. You just ground all the rest of the towers and tie them off to ground through a series LC network, so you could play around with the phase and the current. But it's if you put two antennas in a field, antennas are forgive me if I'm going on too detailed on this, but to answer your question, antennas are inherently passive devices, obviously, and any given antenna is just as good at receiving as it is at transmitting. Okay, so if I put a signal into antenna number 1, I will induce current into antenna number 2 because this is a transmitter, this is a receiver. Same thing here. If I feed a power into tower 1, I get current back out of tower 2. Same thing. Okay, if the amount of power I feed to each tower and the relationship between them separation wise, and also to some extent the height, is a certain way to make the pattern I want, power from the power I feed this tower will be overcome by what's called the mutual coupling, the power fed from this tower back to that one. And when that occurs, the net power flow out of this one is back, not out. Now it's still making a field, but the mutual impedance, which is the sum of all the couplings from all the towers in the field and what's called the self impedance, that if that were the only tower in the field, all that adds up, all the currents add up to make power coming back instead of going out. Now we could just tie that tower off to a dummy load and burn up the power, And that's entirely possible. And there are some very rare circumstances in which that's done and the FCC approves it. You got to really convince them, but they will allow it. And we can talk about specifics, but we won't. The conventional wisdom, though, is to make it efficient by feeding that power back into the system. So it's just like any other tower as far as the phaser is concerned, but the sign of the overall tower, S-I-G-N, not S-I-N-E, is reversed by 180 degrees. So power is recycled, if you will, is sucked in by that tower, fed back into the phaser, and contributes back to the power divider point, so it maintains the efficiency of the array. And that's a negative tower in a nutshell.
Cool.
It's not any different. You can't tell it. By looking at the parameters, you can't tell it. You can model it and say, oh, look, that tower is going to be negative. And if you go out with a bridge, you'll see it, because the bridge will null below zero. Turn the bridge around, all of a sudden it nulls, because the tower is the source and the phaser is the load.
Right.
So
they're going to say the bridge is just looking at the net current flow.
Right, that's right. The bridge is telling you which way the power is flowing, and at that point, you actually there's no such thing as coax. Well, there is coax matching for a negative tower. It's very different than it is for a positive tower. In a DA, you want to match you want to make each ATU a reasonably good load on each coax. It's not crucial. It does minorly affect bandwidth, but it does majorly affect the stress on the coax. You want the coax to look at a good load, because otherwise you get hot spots, high current spots every quarter wave, every half wave, high voltage spots every opposite half wave. That's bad for coax. With a negative tower, it's more complicated because the load is at the phaser and the source is the tower. So you have to think backwards. You actually can play with the network feeding that tower in the phaser to make a more or less a good 50 ohm load, then go out to the tower and play with the ATU there to get the parameters, which is head explode. But I have done that. There's a 5-tower array we did in Georgia some years back, 50 kilowatts. 2 of the towers had 10 kilowatts negative power in them.
Wow.
So their coax matching became a serious concern, because you got 10 kilowatts of power going through a coax going backwards. It sure wants a good load for that. Yes.
Yeah. Well, and especially if it's one of those. No, we're only feeding 2 kilowatts out, and it's like, but if you're bringing 10 back, that's intriguing. So, okay, what's the best way to deal with low impedance towers in a directional array? Minor changes in soil moisture often greatly affect their impedance. And so that's fair enough. How do you keep a low impedance tower stable?
Well, the short answer is sometimes you don't. The best you can do is nibble around the edges, like we talked about earlier. Make sure that your I²R losses, your actual resistive losses in the whole system, are as low as possible. It's incumbent on you to have a robust ground system, to have it in good shape, to have all your straps as wide as possible, all silver solder everywhere, everything stable as possible. The shunt elements in your ATU need a big wide strap from there to the base of the tower. You need a good robust strap from the transmitter building out to the tower. The idea is that if you're stuck with a low base impedance from the tower, you want to make every other loss in the system, every other resistive loss in the system, as low as possible. That's the only thing you can.
Yep. And I mean, that comes back to and I know you're the silver solder, and I mean, I'm a little more, I don't know if pragmatic's the right word, but I told people, I said, I just want an exothermic connection, whether it's silver soldered, whether it's brazed, whether it's Cadwell. I love Cadwell, but that doesn't work so well for strap, obviously.
There are Cadwell molds for strap, but yeah, you got to be really careful, because you'll burn that strap up in a hurry.
Yeah, and I mean, I watched a guy trying to braze oxyacetylene with strap one day, and he vaporized a good chunk of it before he found the right heat setting.
Yes, that's a matter of skill and experience. That an oxyacetylene torch is the 800-pound gorilla on the bus. You give me a big enough oxyacetylene torch, and I'll cut up a battleship. Literally, that's what they do. So you're talking about 32,000 thick copper, a soft metal with a low melting point, and an oxyacetylene torch. You got to talk to it really nicely. Yeah. You got to kind of ease up to it and make sure it's okay.
That's it. Yeah, none of this put the flame tip right on and expect it not to just create a hole.
Right.
So now, and this is one of the things we talked about before with ground radials, because ground radials are really good for pulling the signal down and spreading it out as opposed to shooting it straight off into space. But they're also underground. Cows walk over them and cut them. Farmers till them up. Various things happen. There have been cases where copper thieves have dug around the base of the tower, snipped them all, and went out to the other end and just pulled them right out of the ground. You know, this is from an article I wrote for our tips and tricks, and I borrowed a picture from Hatfield and Dawson's website, included the link. They've got a lot of downloads there if you're into educational reading. But just using a field intensity meter to check ground radials. Done it?
I
Or
have.
have you? Yeah, hard
And
on the back, but
hard on the back, although they came up with a nice little handle there. That's beats the hell out of bending over. Years and years ago, Lauderdale Electronic Labs, rest in peace, may they rest in peace, had a bunch of little gadget stuff. And one of the things they built was a ground radial detector that was basically kind of sort of like a metal detector. It had a loop on the bottom of a handle and a rectifier circuit and a meter up top. And you could go find the ground radial and walk it out. And if all of a sudden, you know, reading, boop, oh, well, you know, the radial must have ended at that point, or, you know, that.
yeah.
And so, yeah, that was really.
I had one guy once send me a tip, and if you go to our website and go to the support tab to the right, and then under technical resources, there's tips and tricks, and there's if you scroll down far enough, you'll find an article on tracing ground radials. And one of the tips in that one was talking about wrapping a coil of wire around the blade of a hockey stick, so you could just walk out with the hockey stick and actually be standing straight up. Yeah, that's the Canadian coming out, see, because a hockey stick is a troubleshooting tool. What more could you ask?
Well, if you ran into a puck in the wild, you could have an impromptu game of hockey.
You're good to go.
No, you have to have the fight first, right?
Well, yeah, you know, I went to a fight in a hockey game breakout. Before we get too much further, it is 2 minutes to the top of the hour. As always, we are going to run long. Why would I stop? You know, why would I break with tradition at this point? This will be recorded if you do have to step out. Not you, Mike. You're stuck with me until the bitter end. But yeah, Tim Barry mentions that Frank Folsom down in Knoxville uses a device using a tuning capacitor and a neon bulb. So again, a ground radial, if you got anything that can pick up current,
yep,
then yeah, that's a cool idea. The neon bulb is a good idea, fast visual, and so you could mount it all on a hockey stick. Sorry, I'm on a roll now.
Now, there's a fellow up in Tennessee, near the middle of the state, Kevin Kidd. And
yes.
He is the guru of all things ground system. And he has a number of tricks for dealing with the ground systems. And he's got little detector things. He has a way to actually induce like a signal into a coax or something, and then this little detector that he runs along, and he can find where the coax is buried in the ground. He can do that for radials too. And you know, those things are commercially available. They're not cheap. They're $1,000, but you can build a homemade version of it. But yes, they're entirely possible to figure out ways to find coaxes and radials in the ground.
Yep. And it's one of those, I just grabbed the little schematic out of our lightning protection guide on just because of the way that it's all got to tie together, because a lot of people will talk about radials like they're part of the lightning ground, and really they're nothing to do with that. They're the counterpoise. They're just the return path.
Right. The ground system at your tower is just there to make the ground look like a mirror on the other half of a half-wave dipole to reflect the signal on the top.
Right.
Lightning ground, safety ground, entirely different concept. And as your drawing shows here, really the key to all of it is the ground at the surge protector there, where everything comes together. Credit to Clay Fringwald of Seattle, that he said that you don't want ground to have to pass through the transmitter, because your transmitter of necessity lives at the junction of the power ground and the RF ground.
Yeah.
And if you don't have a bypass to connect those two together other than through the transmitter, it's the equivalent of going out, taking your transmitter out to the busiest intersection in the middle of town and nailing it to the middle of the intersection.
Yep.
And what you want to do is you want to build a highway bypass around town so that all that ground current goes somewhere else other than through your transmitter.
Yep. And the argument I've made before is that the folks talking, especially these days, as we get more and more into switching supplies, and less so on AM for us, but others do use them a lot in AMs. We use them a lot in FMs. If you don't have that bypass, then the lightning energy is going to look for a place to dissipate. And once all that current hits the base of the tower, and Earth, which has a finite resistance per foot, you not dump enough current through it, you create a voltage. At that point, it's got to find somewhere else to dissipate. The power company provides millions of miles of wire and ground for it to dissipate on, but the easiest way to get to it is through the switching supplies. Things are going to go sideways.
Right. And I see your little drawing there also shows your ubiquitous ferrites, which is always a good idea to put a ferrite on everything in and out of a transmitter. Power, RF, signal, remote control, everything.
I was making it a point not to mention the ferrites this time. I think I may have developed a reputation, but yeah, absolutely, you got to have the ferrites. And it's like I tell people, on their own, the ferrites don't do a whole lot, but in conjunction with proper grounding and a properly installed surge protector, they can make a difference.
Yes, and note to self, a ferrite should never be hot. If you ever
especially on an AM.
Especially on an AM. If a ferrite is ever hot, go figure out why. Because you've got almost certainly either RF or power, a net current flowing through that ferrite, which you do not want.
Right. Yep. Ideally, especially on a coax, but on AC, anywhere where you've got a feed and a return, the feed and the return should be equal. If they don't, you've got a ground loop or some cause of current imbalance.
Right.
And so that will cause the ferrite to saturate. Yeah.
Right. On a three-phase, you don't put a separate ferrite on each of the three conductors. You put all three of them inside of one ferrite, so
with
that
your return
through the ferrite is zero. Yes.
Yep. Exactly. All right, moving forward a little bit. So general maintenance, there are a few things that you prefer not to see at a transmitter site. The one on the left, this was a air conditioner. They had a window mount air conditioner in as a temporary gesture, and whoever put it in had left the drain plug on the inside of the wall, not the outside. And so the electrical box, that's a 240 volt circuit sitting in that puddle of water. Yeah, I looked at that, said, nope, not working on this. The right-hand side, that was just some creative fuses. Wow. And I have to confess, I did not see that one firsthand. That was scavenged. So horror story time. What's the scariest thing you've ever seen at a transmitter site?
Copperhead about long.
Yeah. See, now I told somebody where I'm from, they're all rattle-headed copper moccasins.
Yeah, in terms of scary installations as opposed to critters, is that what you're asking?
You just just anything come to mind, and I mean no naming names, but anything come to mind.
Well, the most depressing I've seen is transmitters where the building had literally fallen around apart around the transmitter, and at least one of them, they had erected basically what was a tent over the transmitter, because that was almost all that was left of the building. And it just made me wanted to weep. You know? But in terms of scary, I've seen transmitters with all the interlocks defeated. And just sitting there, conventional tube type transmitters where there were exposed high voltage. I've known several engineers over the years who got killed because of careless interlock bypassing. And I mean, I don't want to die. I'm going to die sooner or later. Let's not have it today. With apologies to the Klingons, with all due respect, today is not a good day to die. So I do defeat interlocks from time to time in our work on transmitters, and one day that may come back to bite me. I hope not. But we are very, very very careful about that sort of thing, because you
Yep.
can kill yourself.
Well, and where it becomes a challenge is if you have to defeat it for some reason, that's one thing, as long as you remember to put it back when you're done,
Put it back.
because otherwise the next guy may not double check to see that it was defeated.
Right. Put the
Yep.
interlocks back, close the covers. I know engineers who walk into a site they maintain, and it feels like they just stepped out for lunch, because even though they haven't been there for a year and a half, because the covers are off of everything. And a lot of times blocks are defeated. It's like, folks, don't do that. You're not doing yourself any favors, and you're putting the next guy in harm's way. Don't do that.
And if I walk into your site and see a bird's nest in your ATU, you know there's going to be a picture taken.
Or ants in your bowl insulator.
Yep.
Yeah.
And another little note, when you're doing your little physical inspection, take a look at the static drain choke. And if it looks like that, it's probably not conducting a lot of current anymore.
Yep. And if you see a static drain choke like that, make sure that the end with the widely spaced turns is on the hot side. I've seen them put in backwards before too.
Yep, nope, that's a good point as well. And last but not least, somebody had asked what the best way was to bond ground connections in the advanced questions. And my answer is always get the owner to do it. And this is a site in Arkansas, and bless his heart, the owner takes a serious interest in his facility. He not only knows where it is, but he knows firsthand where all the grounding is and everything. He's, everything was an education on that install, and it was beautiful like that. But I'd come in because they'd been having some power supply problems, and we got talking, and he's like, yeah, he goes, I don't understand. We got this all new ground system. And I walk around and there's a compression clamp, one of those little screw type ground clamps to hold the 2-gauge wire to the ground rod.
Yep.
And I grabbed it and I'm sitting there wiggling it around. And he goes, that was tight like 3 months ago. And it's like, yeah, compression, copper compresses, it's malleable. So it goes to displace the air. And he's like, well, we've got to fix that. And there, 9 o'clock at night, he's out there brazing the thing together, and it's like, that's the kind of ownership I like to work with. But yeah, it was very much, he took it right on himself. We're going to fix this, and we're going to fix it now. So, yep, that's my favorite, to get the owner to do it.
Whenever I do anything with the ground systems at all, it's all silver solder, 15% silver solder, or CAD weld. Especially outside. Don't ever put soft solder outside. It will deteriorate over the years.
Right.
In an ATU, in a phaser, that sort of thing, soft solder is okay there. For no other reason than the higher temps for silver solder, it's very difficult to do that without ruining the rest of the box. You have to take special techniques, and even people like the phaser people, Kintronics and Phase-Tech and those folks, they'll use soft solder inside their phasers and their ATUs, but they're very good about it. They're very careful about it. So don't ever leave soft solder exposed to the weather, ever, ever, ever.
Right.
And don't use compression fittings. CAD weld it, silver solder it, as you say. Never use a compression fitting on a ground rod. It will come back to fail on you. It will fail on you.
Yeah, anytime that you have a stranded conductor going into a compression connector, you can assume that you're going to have to tighten it multiple times before you've displaced all the air.
Right.
And I mean, that comes back if you're using stranded wire in a breaker panel, which a lot of electrical inspectors will shun you for, and rightly so. But anytime you've got a stranded wire and something that clamps down, put it in, come back a week or two later, tighten it up. Come back a month or two later, tighten it up, come back a year later, tighten it up. And at that point, you could probably say you're okay. But don't ever assume that it's going to be okay the first time. Clayton asks, is it a good assumption the antenna monitor has been hit by lightning if all parameters are wrong? If so, what could be improved in grounding? Should I check the building ground? So that's what more information would you need to be able to answer that?
If every parameter is in an antenna is wrong, antenna monitor is wrong, the next question is the common point good? That's a good indication. Are the monitor points under their limits? If so, the array's fine and your monitor is dead. The idea that all of them are wrong probably means there's something wrong with the reference module system in the antenna monitor, because that screws up everything. And honestly, at that point, you have toroids or do you have loops? You could go back and you could buy like not phase tape, phase master, polyphaser. They make surge protectors for anything. They'll surge protect everything from hell to breakfast. But you can get little modules from them that you can pass the antenna monitor samples through. But as long as you pass them all through it, whatever phase shift they affect will change everything equally. You can put that in front of your antenna monitor as a protection level. That's overkill most times. But every now and then you do have to have something like that. One of our customers is WWL down in New Orleans, and about every 3 or 4 years, some lightning comes along and blows up their antenna monitor, and they send it up here, and we fix it and send it back to them. And that's just the price of doing business.
And that was another question, a little side note and a little bit of promotion. You guys do have a pretty well-established repair shop there too.
We do, and one of the things we do repair are Potomac AM19 antenna monitors. We've developed a number of retrofits for that, and that's a very routine thing. We do a number of retrofits and improvements on Harris SX and Gate series transmitters, and a number of other unique widgets and widgets, and lots of stuff. If it's broke and you can put it in the box and send it to us, chances are, if it's worth fixing, we can fix it and send it back.
Cool. And I mean, I remember seeing your little replacement for the controller for the SXA series. Many years ago. The little screen that you did for that. And he's like, I know I've got one around here somewhere. But
yeah, we've sold over 100 of those.
Those are a cool little device. Yeah,
our latest thing is that, and with the blessing of the folks at BE, we have a little interface board that if your BE IPA out of an A or B series, not T series, A or B series dies, the devices in that are no longer available. So BE wants to sell you an Olenos 500 watt-ish transmitter cider thing, which is great. That's a affiliated product of theirs. But the problem is that if you just put it in the transmitter, the automatic power control circuit will not work because the APC needs a metering from the driver to say, I am putting out enough power, don't try to run up the screen away if the drive is low. So we make a little circuit card. Unfortunately, they're all up in the front office, but it's 2 by 4 inches. It plugs into the DB25 on the back of the Olenos. You plug the old IPA plugs into it. You dwindle a couple of pots. You change a resistor value on the APC, and all of a sudden, the transmitter thinks it's got the old IPA in it. The front panel metering works. The APC works, and everybody's happy. And it's a couple $100. And cool. This is great. I said, well, you want to use it? They said, no, we'll just send people to you. Hey,
there you go.
Works with me.
Yep. So now I got one other question, last question. And we talk a lot about AMB and ancient magic and how you're almost in some cases defeating the laws of physics. You do happen to be the only guy I know that's capable of setting a swamp on fire.
Thank you very much, Mr. Welton. I found the only transmitter site that will simultaneously dry enough to go up in flames and wet enough for my 4-wheel drive Jeep to get stuck in it. It was about 1.5 miles from Sabine Bay, and it's a site that it's depending on what time of year it is, it'll be dry, it'll be wet, and it had crusted over, but it was wet underneath. And I got about halfway out to the tower, and there went the Jeep, and tried to rock it out, standard 4-wheel drive technique. The cat converter overheated and set the grass on fire. And you can see my poor little car was a total loss, along with most of my test gear.
Ouch.
Yeah. So let me tell you what, I mean, if you set your vehicle on fire, you have to answer a lot of questions.
I'm pretty sure you do, especially in the field in the middle of nowhere.
Yes, thank God nothing else went up. The fire department came out and put out the fire, not before they could save my car, but at least they didn't burn the transmitter. I didn't burn the transmitter building or the ATUs down, which I had visions of, my entire career going up in flames.
But, and I'll have to confess, I did scavenge your Facebook for that particular photo.
Oh, that's all right. Yes, I deserved it. But I had to, first off, I had to answer a lot of questions from the fire department. Then I had to answer a lot of questions from the police department. And then I had to answer a whole boatload of questions from my insurance company, which finally paid off. But everybody wanted to make sure that I didn't torch my own car. It's like, folks, really? No.
Yeah. It's I guess not an uncommon occurrence, but no, it's just like I said, being able to set a swamp on fire, that's quite an interesting art. Well, folks, we've hit the quarter after the hour mark. Thanks for all the folks that managed to stick with us. As always, this webinar, like all our webinars, will be archived as soon as Mr. Disembodied Voice Edward gets her done. Ed, thanks for bearing with me because I know I'm keeping you up past nap time too, and I really appreciate you hanging with us. We've got a bunch of other resources, Waves newsletter, YouTube channel. There's all kinds of online stuff, barrymichigansbdr.net. There's the broadcastengineering.info. There is a Facebook page and a group for everything, transmitter sites, broadcasting club, radio engineers, studio stuff. You pick a topic, there's a Facebook page for it. So on that note, Mike, I really want to thank you for taking the time out of your day to be with us. It's been really good, and apologies again for giving you the times in Eastern instead of Central.
No, that's all right. At least I'm not in my pajamas. Thank you. It's my great honor to be invited to something like this and to present my poor understanding of reality. And I look forward to seeing you again soon.
Awesome. And folks, thank you all very much for being with us, and we will see you. Let's see. So I'm on the road for a little while. We'll be taking a break until after the 4th of July. So somewhere in July again, we'll be talking. Keep an eye on our website and our social media, and we'll let you know when we're back again. Thank you very much.
Birmingham. So.
Yes. Well, we'll see you in Birmingham in August. Yeah.
All right. Take care.
Thank you, folks. Have a great day.